What's poppin', dogs? Mr. Allen here, simplifying some exponential expressions in this video, and we got a couple doozies ahead of us right now. First one, I've got 3 times x to the 7th y to the negative 4th z cubed over 2x to the 4th y to the 10th z squared, all raised to the 0 power. Whew. Now, normally what I'd do is I would simplify on the inside here first, make things a little bit easier, then deal with the exponent on the outside. But we have a rare mathematical gift here, guys. And if you remember, anything to the 0 power is 1. That's right, 1 and done here with this problem. That is pretty wonderful. But if you're like, wait, why is anything to the 0 power 1? If you're curious about that, like many people are, why is it not 0? Let me sauce a little mathematical proof your way here, okay? Let's say I have x to the, let's go with x to the 4th power. And I divide that by x to the 4th power. Now, anything divided by itself would equal what? It equals 1, right? If I do 5 divided by 5, that's 1. 10 divided by 10, that's 1. A million divided by a million, that's 1. Exponent properties, what do we do with our exponents? Well, I subtract my exponents when I'm dividing with like bases. What's 4 minus 4? Anybody? Count on your fingers here. It is 0. So x, some number to the 0 power, ends up equaling 1. And I know that's a bit of a street math scenario here, mathematical proof, but, you know, just kind of showing what's up here. If you mathematical nerds out there really want it in variables, we can do like x to the n over x to the n, and we can define n as some number, you know, and x is some number, not 0, blah, blah, whatever, dude. X to the 0 is 1. Anything to the 0 power is 1. I'm not even going to get into 0 to the 0 power because I don't want to get into a mathematical fight with anybody. I'm going to move on to this next one here. 0 to the 0 is disputed by many, okay? All right. We got a whole mess here, raised to the negative 3rd power. So 2 options of what you can do here, guys. We can either flip the inside, make that a positive 3, or deal with the inside first, then flip and make that a positive 3. I'm going to deal with the inside first here. And that's where like a lot of confusion with exponents comes into play, because you do have a little bit of play in what you do first. I'm going to go about it in what I think is the best way, okay? So I have 6 over 2. Well, let's see. Let's throw a fraction together. 6 divided by 2 is 3. I have x to the negative 1st, x to the 4th. Well, like bases, we subtract our exponents. I always go with the bigger exponent, my denominator in this case. 4 minus negative 1 is going to be positive 5. So we have x to the 5th right here. Right? If I had 4, I'll do a little side math here. 4 minus negative 1, you add them, it becomes 5, okay? Now I have y to the 4th over y to the 8th. Well, again, my larger exponent's in the denominator, so I'll do 8 minus 4, which is 4. We get y to the 4th in the denominator. Some teachers just always do numerator minus denominator, so 4 minus 8, that's negative 4. How do I make it positive? Move it to the denominator. To each of their own. Last one here, I got 2 minus negative 6, because 2 is the larger. That's going to be z to the 8th in my numerator, and this is all still to the negative 3rd. Now, we're going to deal with that negative exponent outside by flipping the inside. You could distribute your negative exponent and then you just have to shift everything around anyways. So I don't see the point in doing that. We're going to just flip it. I'm going to have x to the 5th, y to the 4th, over 3z to the 8th, all raised to the positive 3rd now. Now we're ready to rock and roll and finish this thing off. We're going to distribute that exponent in power to a power. We have to multiply our exponents. So 5 times 3 is x to the 15th. 4 times 3 is y to the 12th. Then don't do 3 times 3 is 9. This is really 3 to the 1st power. So we end up getting 3 to the 3rd, which is 27. That is a common error that people make with exponents, is they start applying exponent properties to our coefficients. No. That's 3 to the 1st. So then we get 3 to the 3rd, right? Do not multiply that 3 and 3 to get 9. You're going to lose some points. Then I've got 8 times 3 is 24. So we get z to the 24th power. Final answer here. That's dope stuff. All right. That's it. If you guys have any questions, pop it in the comments. I hope you enjoyed my informal proof of why anything to the 0 power is 1. All right. Thanks for watching, you guys. Have a wonderful day.